so this is part 2 of the integration with fractions video. So if you remember, I said you need to use the AB method when you have 2 factors in the denominator, okay? What you do is just written a little differently here, but hopefully you agree that this is the same thing as writing this. Okay, so we are going to do the AB method, but we can't do it the way we normally do it, where we just say A over this and B over this, because they already have a common denominator. So what we do is we actually split it differently. So we say that this is the same thing as A over x minus 3 plus B over x minus 3 squared. So we're just really manipulating it differently, and if you think about it, this process, if I was going to find the common denominator, be similar, I need to multiply this guy by x minus 3 over x minus 3, so it's not really that different. So I'm going to do just that. I'm going to figure out what A and B is if this equals this. So it's just a tweak on the AB method, and you have to do that when your factors in the denominator are the same. So instead of just doing one factor here and one factor here, you do a factor to the power of 1 here and a factor to the power of 2 here. All right, so then we need to figure out what's what. So we don't care about the integral signs. We just know that this equals this, and we're going to do some algebra. So to get a common denominator, all I need to do actually is multiply this by x minus 3 over x minus 3. So I end up with x plus 1 equals A times x minus 3 plus B. And if you remember, I want to solve for A and B, and how I do that is by letting x equal something that's going to make my life simpler. So I'm going to let x equal 3 in this situation, so I'll be able to solve for B. So if x is 3, B is 4. Perfect. And then I'm going to plug B as 4 into here to solve for A. So then I have x plus 1 equals A times, no, I'm not going to do that. I am going to not remember what to do. Let x equal 0. Oh, yeah. I'm going to let x equal 0, and I'm going to use the fact that b equals 4. Okay, so I'm going to plug it back in there. So 1 equals A times minus 3 plus 4. So I'm going to bring the minus 4 on the other side. So minus 4 equals A times minus 3. So A equals, you said low battery, better not stop on me. What did I do? Oh, 1 minus 4 is not minus 4. This is minus 3. So A equals 1. Okay, so now I have A and now I have B. So I'm going to plug A and B back in. All right, so I'm going to go all the way back here, and I'm going to plug A and B back in. So this whole thing is equivalent to, so A is 1, so 1 over x minus 3 plus B, which is 4, over x minus 3 squared dx. And you have to be careful, you have to put the A and B in the spot where they originally were. Like A was over the power of 1 and B was over the power of 2. They need to match. So now we go and do the integral, okay? So this is just a natural log question. So it's the natural log of x minus 3 plus. Now we get to this guy. It is no longer a natural log question. Now this question is a substitution question. So I'm actually going to do some simplifying first. I'm going to bring the 4 on the outside, and I'm going to write this guy like x minus 3 to the negative 2 dx. So I need to find the integral of him. So I need to do substitution. So I'm going to let u equal x minus 3, fu is u to the negative 2, du dx is 1, so du equals dx. Okay, so I'm just going to take this piece, I'm going to deal with him. So this whole thing is the integral of u to the negative 2 du. So u to the minus 1 over minus 1 plus c. So minus 1 over u plus c. So u is x minus 3, so minus 1 over x minus 3 plus c. So this is the integral of that. So then I'm going to go back. Oh, I'm sorry, I can't see most of that. It's going to be okay. You guys got this. You're so smart. Okay. So now I'm going to put this guy back in here. So the final integral is just this piece here. So the natural log of x minus 3 plus 4, it's actually negative 4 over x minus 3 plus c. So whenever you have two terms that are the same underneath, you're going to have to use that variation of the AB method where you do something to the power of 1 here and then some to the power of 2 here. And then also when you use this strategy, you will always end up having to use substitution on the second integral.